Hi, I'm Ted Bone. I'm going to tell you about CutoffPredictor, a consulting project I did for Valor Water Analytics. Consider a water utility delivering water to customers. Typically, customers pay for 1 month's water while they receive the next. If customers are late, particularly late enough to get their service cut off, this can represent a loss of up to 3 months of revenue and water for the utility. Ideally, utilities would like to identify at-risk customers before these cutoffs happen and approach them about a payment plan. My solution is CutoffPredictor. With this dashboard, the utility can monitor cutoff risk in their customer base. It'll show the predicted number of cutoffs, the total revenue loss represented by those customers, the total volume loss as well. And it will map out these customers showing their risk level and their volume usage. It will provide a breakdown of the customers by customer type, municipality, or meter size. It shows a list of customer information down below, and it allows the utility to adjust the risk threshold to identify higher priority customers. The tool draws on the utility's database. These consist of histories of billing and usage, customer metadata, and for training the model, we must have cutoff dates. Not all utilities store that information though. So I had access to one utility that did. I could only see a subset of their total database consisting of 2,400 customers, most of whom were commercial. In this subset, there were only 73 cutoffs, or 3% of the data set, so it was highly imbalanced. After preparing the data and cleaning it, I moved on to feature engineering. The idea here is that customer behavior can signal an impending cutoff. For example, late payments often indicate an impending cutoff. Similarly, strange changes in volume usage can signal impending cutoff. For example, a lot of zeros or a sudden spike in usage. So we're trying to detect anomalies in usage or late payments. For this, I went to the customer histories, some of which contain cutoffs, and I clipped out sample windows n months long. For those customers with cutoffs, these windows were placed immediately before the cutoffs. For other customers, I placed the windows randomly. Within these windows, I computed the fraction of late payments and a variety of statistical metrics to capture anomalies of usage. That, combined with customer metadata, became model features. The model then can be applied to make a prediction using the last n months of history. To train the models, I divided the data set into training and test subsets, and I oversampled the training data set to compensate for the small number of cutoffs. I trained both random forest and logistic regression models, and over a variety of window lengths from 4 to 24 months. To evaluate which model was best, I used cross-validation on the training data set. The best model was random forest with a window length of 18 months. And on the test data set, we got a metric, an area under the curve for the receiver operating characteristics curve of 0.922. The most important features were these usage anomaly metrics and the fraction of late payments, although customer metadata also played a role. Again, my name is Ted Bone. My degree is in hydrology and water resources from University of Washington. More recently, I've worked with Arizona State University. I have experience working with large geospatial data sets, forecasting the flows of large rivers, and in my spare time, I play with a Brazilian music band. Thank you.